All right, this video is an introduction to Riemann sums. So we're going to be doing a left endpoint, right endpoint, and midpoint. So I'll explain what all of those mean. So first, let's look at our function. We're going to consider a function and it's on 0 to 4. So this red line is our function f of x equals, in this case, it's x plus 1. And we're going from 0 to 4. And so what we're doing here is we're trying to approximate the area under the curve. And what that means is the area from the function to the x-axis. So just like this. This is the area that we're approximating. And what we're going to do is create rectangles underneath it that give us that approximation. So the first one is a left 4. So that means we're going to take this area, this width here, and cut it into 4 parts. So you can already see that it's from 0 to 4. So we're going to go like this. If we put in 3 lines, it breaks it into 4 parts. So let's take a look and see what this looks like before we start. So this is a left endpoint. So you can see we're using these rectangles to approximate the area that's under the curve, which is this. This is what we are approximating. So you can see from the line to the x-axis. And to do that, we're making these little rectangles. So the left just means we're using the left endpoint. So in this area, in this first partition, you have a right endpoint and a left endpoint. And we want the left. And then in this partition, you have a left endpoint and a right, up here, sorry. So left and right. And so that would be the one we want. And so what we're going to do is just go from the left across to make these little rectangles. So like this. You're going to put a dot here and then draw across. So again, in each part you have 2 endpoints, a left and a right in each partition. And we just move across. So the way I like to look at it is, if you think about it, you've got these endpoints where each of those partitions are broken apart. And you just start on the left and work your way across, drawing these little rectangles. So if we shade them in, oh, it looked horrible. That way we get our area. So to approximate our area, we just have to find the area of all these rectangles and add them up. And I'm writing them upside down because, well, I need to have more room. So the width on each one is 1, and we like to keep the width the same. I mean, you can make it anything you want, but we're using 1 here. And so the height of the first one would be at 1. And the height of the second one is at 2. And the height of the third one is at 3. And then the last one's height, this one has a height of 4. So if you remember, area of a rectangle is length times width. So this would be 1, 2, 3, and 4. And if we add that up, we get 10. So our sum of our areas is 10, but this would actually be an underestimate. You can see that all of our rectangles are under, and each one is kind of not exactly what it needs to be. So then you would think, oh, well, why don't we try it from the right then? So let's partition this one into 4, from 0 to 4 like before. And we draw our 3 lines. And then now, of all of these endpoints, we're going to be looking at it from the right. So if you look at the first, that would be the left, that would be the right. In the second, that's left and that's right. And in this one, that's left, that's right. And so in the last one, that's your right. And so the way I like to look at this is you start from the right and work your way across. So this is what our rectangles will look at. You can see that for this partition, you see you have a right and a left. We want the right. And then that would be the right for this one. And that would be the right for this one. And that would be the right for that one. So what I'm saying is you start on the right and just work your way to the left. And it will draw your 4 rectangles. So we would go to the right, go to the right, fill that in, go to the right, and then go to the right. And now we have our 4 rectangles. So we do the same thing we did before. We're going to find the area of that one, that one, that one, and that one. If you're kind of noticing this, our widths here are all 1. And what our heights are the y values. So if you're starting on the right, what we're really doing is plugging 4 into our function. That gives us a height of 5. We plug 3 into our function. That gives us a height of 4. We plug 2 into our function, which would give us a height of 3. And we plug 1 into our function, which would give us a height of 2. So the heights are really the y values. That's all we're using here. So this is 2, 3, 4, and 5. And so our area would be 2 plus 3 plus 4 plus 5, which is 12. And this is an overestimate. So we know that our actual estimate is somewhere in between those two. So why don't we try something in between? How about the midpoint? So let's start it by breaking it apart just like before. So we're going from 0 to 4. And by the way, we're going to be calling this our B and this is our A. So the starting is your A, the ending is your B. And then we break it into our 4 parts just like before. So 3 lines. And now we have our 4 partitions. Right? Again, it's 1, 2, 3, and 4. Now, the difference here is we're looking for midpoints. So we go in the middle. We're not using the left or the right. We're using the middle. So it looks like this. So in our first partition, we would have our left and our right, but we want the middle, and the middle, and the middle, and the middle. So it's the point that's in the middle. The midpoint is literally the midpoint of these 2 points. And so if you ever needed to find it, it would literally be the average of the 2. So if we did 3 plus 4, that's 7, divided by 2 would be 3.5. 2 plus 3 is 5, divided by 2 is 2.5. 1 plus 2 is 3, divided by 2 is 1.5. So it's just the average of the 2 to make that midpoint. So that's what we're using here. And then we just draw across like that. And then that makes our rectangles. So we fill them in. And then again, the area is the same thing. We're going to find the area of the first rectangle, the next rectangle, next, and the next. And they're all a width of 1, just like before. But the heights now are 1.5, 2.5, 3.5, and 4.5. So you can see that it's 1.5, 2.5. And what that's being done is if you plug 0.5 into our function, we get 1.5. Plug 1.5 into our function, we get 2.5. But our areas are 1.5 plus 2.5 plus 3.5 plus 4.5, which gives us an area of 12. So that means it's 12, and this is an exact, actually. And let me show you why, because my picture, you can kind of see it, but that triangle fills in that triangle fills in that triangle. We have a line here, so that triangle is filling in that, and so on and so on. So we get 12, which is a better estimate. It's exact. So now the last question is, if we use more rectangles, what would happen to our estimate? So in the next video, we're going to be using more rectangles for some similar problems to find our estimate. So let's take a look here. There's our midpoint, or that's our left, our right. Sorry, let's go back to our left. What would happen now if I use more rectangles? So you can see it looks like it's filling it in, right? The underestimate is less of an underestimate. So if you use a lot of rectangles, it's going to give you a much better estimate. This will be really, really, really close with 200 of them. So if we use more rectangles, our estimate gets better. We get a better estimate. All right, thank you. Oh, let's go over it real quick. So we have our left, you start at the left, right, you start at the right, and midpoint, we take the middle. And you're always focusing on each partition.